Right. Hello and welcome to Quantum IAS. This is day 4 of daily answer writing January, and we are still practicing mechanics questions. So let us start with question number 1. Though the question number 1 is basically two bodies are placed at a distance d apart. Show that at this position where the gravitational field due to them is 0, the potential is given by this. Now you need to understand this is a 10 marker question. Both questions are PYQs only, right? Both the question are PYQ. And now try to understand in the first question, they have given a condition. This is the condition is given, and this is what we need to find. So if you see here, there are two keywords. That is, one is gravitational field and one is the potential, gravitational potential. So which one we should take in the introduction? So if I talk about the introduction part, from where we should start the introduction, right? Should we start with the potential or should we start with the gravitation itself? So I will suggest you to start with the gravitational field. Right? Just define the gravitational field, right? So gravitational field is basically an area up to which the influence of a massive body that has mass can be extended into the space around itself, right? So if this is the mass around itself, what is the area of influence? That is basically its gravitational field. We are talking about the qualitative aspect as of now, right? Which produces an attractive force on another massive particle, right? So it's a simple definition, but it's a pretty comprehensive definition, right? Now understand, this is gravitational field that we have talked about in the introduction, right? You should know that the gravitational field due to a point object, right? So we will write gravitational field due to a point object can be simply written as minus gm by r cap, minus gm by r cap, right? Where g point is the gravitational potential due to the mass point, m is the mass of the particle, g is the gravitational constant, r is the distance from that point, massive point, to the space. Let's say this is the r. ऐसे दिखा दोगे, that will be sufficient. Now what you need to do, first you need to solve the first portion, first the condition where the gravitational field will be the 0. So you will say, considering the above situation, let us take two masses m1 and m2. Again डायग्राम जो वो साइड में बनाओगे, बॉक्स बनाओगे, that all thing I am writing in your answer sheet जब evaluation के लिए आ रहे हो. I'm just focusing on the explanation part here. So this is the d distance between them. So let's just say at x distance from the mass 1, this is d minus x. The gravitational field between them is 0. See, this is r square. Now understand one thing, gravitational field of a particle is the property of that particle. It will not alter due to the other charge place. समझने की बात ये करो कि अगर इस पॉइंट पर, कॉन्सेप्चुअली बस समझना, लिखने की जरूरत नहीं है, इस पॉइंट पर अगर हम बात करें ग्रेविटेशनल फील्ड ड्यू टू वन, विल इट चेंज ड्यू टू द प्रेजेंस ऑफ m2? तो नहीं, दिस g1 will not change, but due to the presence of m2 will g net at this point will change. So yes, ठीक है। तो हमेशा याद रखना कि ग्रेविटेशनल फील्ड जो है वो एक मास की प्रॉपर्टी है इन अ स्पेस कोऑर्डिनेट, ओके, and as it a vector field, so g net it can be 0. So when g net it can be 0, we can simply see that, say that g1 plus g2 is 0, g1 plus g2 is 0, right? So इसको आगे लिखोगे, सिंपली लिख दोगे तो क्या आ जाएगा, g m1 by x is equals to g m2 by x minus d का होल स्क्वायर, ठीक है। treating this direction as positive direction, I think you can pretty much solve it. So from here x by इसको ऊपर जाते हैं, x minus d can be written as root under m1 by m2. You know the ratio and proportion, डिविडेंड लगा लो, तो x by d मल्टीप्लाई कर लो, जैसे करना कर लो, इट इज इक्वल्स टू रूट अंडर m1 by रूट अंडर m1 plus m2, right? Or simply from here you can write d, right? So this is the x, ये पोजीशन है जहां पे इलेक्ट्रिक फील्ड जो दोनों के कारण है वो 0 हो जाएगी, राइट? नाउ इफ आई टॉक अबाउट द पोटेंशियल, राइट, इफ आई टॉक अबाउट पोटेंशियल, एक और चीज है जो कंक्लूजन में लिख सकते हो, मैं यही बता देता हूं। कंक्लूजन में एक ग्राफ तुम ये बना सकते हो कि अगर तुम्हारे पास एक m1 है और एक m2 है, राइट, सो व्हाट इज यहाँ पे इफेक्टिव इलेक्ट्रिक फील्ड इज 0। यहां अगर जाओगे तो क्या होगा, ड्यू टू m2 the electric field will be, sorry, the gravitational field will be more as compared to m1, so effectively it will be in this direction, that is in the positive direction, right? So this is point ke is side electric field will be something like this, or gravitational field, okay, and if you come this side, yahan par kya hoga, is side zyada hoga aur is side kam, so it will be negative. So this is also you can draw in the graph g versus r, right? So ये conclusion में draw कर सकते हो, I'm just stating because यहाँ पे मैंने ये बताया, okay, and this point is x and this is d minus x. Now try to understand, we have got the point where the electric field is minimum. Now we should write that E is equals to, और G बार बार ये E लिखा जाता है, G इलेक्ट्रिक फील्ड और ग्रेविटेशनल फील्ड माइनस डेल्टा V, ठीक है, ये लिख सकते हो, राइट? सो जस्ट एस्टैब्लिश अ रिलेशनशिप between them, right? This you can write, but more important is that you should write the gravitational potential definition, right? So gravitational potential at a point, you should be writing the definition. So definition of gravitational potential you will write, right? What is the definition? If you bring a point from infinity to a point, right, in the presence of a massive particle, let's say if this is a massive particle, and if you bring 1 unit of mass from infinity to a certain point, then the energy between them, potential energy between them will be the gravitational potential at that point. So you can simply mention it, right? So gravitational potential is the work done in bringing a unit mass from infinity to a point, right? So for m and r, what can be v? So potential is equals to minus gm by r. The potential between them is equals to minus gm by r. Again, it's a scalar quantity, so it can be simply added. So what we need to do? So v net at that point will be v due to 1 plus v due to 2, potential due to 1 plus potential due to 2. Acha, one more thing. If you will write delta v, delta v, delta v, and delta v, right, it will represent a more accurate picture. Why? Because अलग बात है, क्वेश्चन भी ग्रेविटेशनल पोटेंशियल लिखा होगा, पोटेंशियल लिखा सीधा, राइट, बट difference in potential is always measured. Potential cannot be measured, right? There should be a reference point from where measuring that potential. ये सब चीजें लिख सकते हो if you need. So put the value, so it will become gm1 by x plus gm2 by d minus x. बाहर है नेगेटिव साइन. अच्छा, एक चीज प्लीज डू वन करेक्शन हियर. इट इज 2m1, ये मिस हो गया था. v equals to minus g by d m1 m2 plus 2 root under m1 m2. This is the correct answer. Just put the value, so it will become minus g m1 x1 is root m1 plus root m2 upon d root m1. From above we can put plus m2. We have taken g outside, so what will be d minus x? So d minus x root under m1 m2 into d minus this. तो ऊपर क्या बचेगा? रूट अंडर m1 प्लस, यहाँ क्या आ जाएगा? d minus x करोगे तो ऊपर रूट अंडर m2 और नीचे क्या बचेगा? रूट m1 प्लस m2. पुट द वैल्यू, माइनस ही करना है सिर्फ. रूट m1 m2 upon d root m2, right? Take this outside, so minus g yes, ये कट के रूट m1, ये कट के रूट m2, राइट. सिंपली यहाँ तो आ गया सीधा माइनस जी, ये d बाहर आ गया, माइनस जी बाई डी m1 इंटू m1, बस मल्टीप्लाई कर दो, m1 m2 प्लस 2 रूट अंडर m1 m2, राइट. नाउ व्हाट will you conclude? In conclusion, you can write what happened when m1 equals to m2. What happened when m1 equals to m2, right? Next one is the graph that I have shown to you, and next one is the sorry, application of gravitational field and gravitational potential. Both you can write. Okay, so this is regarding the question number 1, right? You can also talk about when v will be maximum. All those things you can talk about in the conclusion, right? But this graph I basically prefer. Rest is your choice. Okay, I guess you know the application of gravitational field and gravitational potential, right? I think you have studied much about gravitational field, potential, electric field and potential in your junior class also. Now let us move to the second question. Second question: the density inside a solid sphere of radius this, where rho naught density at surface, r is distance from the center. ठीक है. Find the gravitational field due to the sphere at a distance 2a from the center. Now understand one thing. In syllabus, you are given with the Laplace and Poisson equation, but these questions can be asked in the electricity and magnetism chapter. So वो जो है वो उधर पूछा जाएगा. Again यहाँ पर अगर potential पूछा आता so we can use that. But अगर gravitational field पूछा गया है तो we will limit our discussion to the Gauss law. We will limit our discussion to the Gauss law, right? So in introduction, what can be the Gauss law? So closed integral g dot dA is equals to minus 4 pi g into mass enclosed. This is the formula, we know that. But first you will write the definition. I'm dictating you, you can write if you want to write. So Gauss law of gravitation states that the closed integral of gravitational field around the loop, लिख देता हूं मैं, states that the closed integral of gravitational field, तुम लोग gravitational field लिखोगे, जी नहीं लिखोगे, gravitational field around a loop is equal to the negative of 4 pi g times, या फिर सीधा -4 pi g times mass enclosed inside the surface created by the loop. ठीक है, अरे inside the volume around a surface, sorry. ठीक है, so अगर this is the surface that I am talking about, if I am taking this surface, then जो भी इसके अंदर enclosed है वो mass चाहिए, right? So this you need to understand. Now in question it is given that spherical body is given there, right? And this is given a radius, and the rho is given as rho naught a by r. ये rho naught a by r, and we need to find the gravitational field at a point 2r. This is 2a. This point we need to find the gravitational field, or any point it will be a spherical surface. एक किसी पॉइंट से किसी एक पर्टिकुलर डिस्टेंस पे कौन सा पॉइंट होगा जो उस पूरे स्फीयर पे लाई करे. तो दिस इज व्हाट वी नीड, वी नो. Now let us solve it. So let's take, if I take a elemental area dA, so this will be the direction, and you know that from this the gravitational field will have a this direction. Attractive hoga, it is 90, right? So what you can write here, that integration g dot dA is equals to, if we solve this thing, it will be simply g dA, and angle between them is cos pi -1, right? So it is basically minus g into dA. Why I'm taking g outside? Because the magnitude of g at a certain point will be remain same around the sphere. We know that. What is the integration of dA? It is simply minus g into, कितना जाएगा इसका, 4 pi r square ना, 4 pi 2a square, minus g into 4 pi 2a square. ठीक है, okay. Now let us calculate. क्या हो रह गया? Yes, mass enclosed. So m enclosed. What will be the m enclosed here? We know that mass enclosed will be what? Rho into dV, from 0 to a. Remember, mass is enclosed in this only, right? याद रखना, where would I mass enclose inside the volume created by the surface? Sorry, so please सही कर लो. जो सरफेस लिया है हमने उसके अंदर जो मास इनक्लोज है वो लेना है, राइट? तो दिस इज द एरिया अप टू विच द मास इज प्रेजेंट, राइट? So we will integrate up to 0 से a only. याद रखना 0 से 2a नहीं इंटीग्रेट होगा. Why? Because the mass is not present there. Always remember this thing. 0 से a rho naught A by R. What is dV? So dV is 4 pi R square dr. dV will be simply 4 pi R square dr. R से R खत्म. ये simply कितना हो जाएगा ये? 4 pi rho naught A, 4 pi rho naught A R dr. So A square by 2. 4 pi dr A square by 2. So it will be 2 pi rho naught A cube. 2 pi rho naught A cube. Now putting this in this equation, so what will be this? You might say, so putting in the above equation, it will be minus g into 4 pi 2 pi A square equals to 2 pi rho naught A cube. तो A square से A cube से A k बचा, right? पाई से पाई खत्म, ये 4 4 16 नीचे अगर this will become 8. Just remove this. हमने एक चीज गलती कर दी है. We have forgotten this thing. ये लिखना होता, तभी वो आंसर नहीं आ रहा था. So if you put this there, so it will be minus g into 4 pi 2a square is equals to minus 4 pi g. देखो यहाँ पर minus 4 pi g into mass enclosed, and this is the mass enclosed only. It will become 2 pi rho naught a cube. अब कर लेते हैं. So it will be again 16 by 8, minus minus खत्म. So g will be simply a cube से a बचेगा, 4 pi cancel out. So pi बचा इधर, g rho naught a 8 by 16, that is 2. So this is just we got the magnitude. G will be simply minus by 2 minus r cap, because we have already considered the attractive nature of the gravitational field here. यहाँ पे already हमने दे रखा है, right? So this is the answer that we have got. Now you need to interpret again. एक तो application लिख सकते हो gravitational field की, गॉस लॉ की, कि सिमेट्रिकल बॉडी के लिए हेल्पफुल होता है, बहुत सारी चीजें. आई गेस यू नो दीज थिंग्स. आई एम नॉट गोइंग टू एक्सप्लेन दिस पार्ट, राइट? व्हाट इज necessary to do here, that you can simply see that it is basically pi g rho naught a by 2, right? So if I put any, let's say, instead of 2a square, if I will put r square here, and it will be a function of r, so g will depend upon r, right? So r increases, g increases. Sorry, one thing, let us solve ही कर लेते हैं उसको. So minus g 4 pi r square is equals to minus 4 pi g 2 pi rho naught a cube, right? So again g 1 by r square. So this you need to explain. Second, you can explain the negative nature, that it is attractive in nature, right? You can also plot the graph of this. You can also plot the graph of this. Now this is a general graph, right? If you have anything, एक और चीज लिख सकते हो, that is if you have anything here, spherical body, and if you are considering any r point, in space, if you're considering any gravitational field, then gravitational field due to this spherical object can be treated as a point object which lie at the center of the sphere, and treating it as a point particle, we can find the gravitational field at a r distance. That means कि अगर हमारे पास एक स्फेयर है m मास का, जो भी मास निकाल रहे हैं हम लोग उसका, जिस तरीके से वेरी कर रहा हूँ, दैट डजंट मैटर, इफ m इज द टोटल मास ऑफ दैट स्फेयर, हम से कंसिडर कर सकते हैं एक पॉइंट मास किधर होगा, उसके सेंटर पर, एंड वी कैन ट्रीट दिस a whole body problem into a point object problem as far as gravitational field is concerned outside that sphere, right? So these 2-3 points you can write in the conclusion, right? I hope you have understood these concept and this solution, right? And please do write the answer. If you're not writing the answer, if you're just listening the solution, it won't help you, because this course is designed in such a way that those who are writing in a consistent manner, they will be benefited the most, right? Okay, so that's all for the day. We will meet on day, I guess, day 5 next day. Thank you, good night, and bye bye.